The network stuff can stay steady, proven, qualified, and the security stuff can be updated independently, right? Even though they live in one device. Chocolate meets peanut butter, security meets the network, right? We find a way to bring them together in a way that they're additive and that they're not conflicting.
Welcome to VB in Conversation. I'm joined today by Tom Gillis. He's the Senior Vice President and General Manager of Infrastructure and Security at Cisco. And Mike Horn, Senior Vice President and General Manager, Splunk Security Products. We're going to be talking about how Splunk and Cisco have joined forces to capitalize on their shared infrastructure and data analysis expertise. Mike, Tom, let's dive right into it and let's talk about the Splunk-Cisco relationship and where is that going and what are you seeing in the market today?
Mike and I have known each other for many, many years, and we finally get a chance to work together. And so we've spent a lot of our time thinking about how can the world's leading infrastructure company and the world's leading security analytics company come together to really define a new blueprint for the post-AI era.
Yeah, absolutely. And when you think about the things that are happening on the threat landscape, AI is having a big impact there. The accelerated time to weaponization of new vulnerabilities. Tom, it used to be, it could take weeks, months, for a vulnerability to become weaponized. And now we're seeing that happen in days or sometimes even hours. So there's a lot of things that are happening in terms of the threat landscape and just the pace of and the need for a new approach to how we think about security.
Mm-hmm. So the combination of the data from Splunk and infrastructure and the ongoing development of new ways of looking at telemetry and analytics is a powerful combination to be able to understand the pace, the scale of weaponized AI and be able to actually anticipate it and even thwart it.
One of the big trends that's kind of washing over us is this movement towards AI-based applications. And I think there's two aspects of an AI-based application that are relevant here. The first is when you think about an AI app, it has this notion of a model, okay? And a model is an interesting character because a model needs to learn lots and lots of data. It learns all your secrets, right? So the thing that you may not realize about a model is when a model learns something, it never forgets. You can't delete data from a model. Like when it knows something, it just lives in there. And so the second thing about a model is that they are non-deterministic. So you don't exactly know how a model is going to answer a question. And so that makes it difficult to think about, here's this model that knows all my secrets that may or may not reveal those secrets if prompted in the right direction. So it's creating fundamental changes to how security controls work. And then this scale argument, right? The scale of AI apps is just massive, right? At Cisco, we build chips for these big AI factories. And so we kind of have a front row seat to this. The speed at which our network chips have to run, 800 gigabits per second per port. So the scale of the data that is being produced and the complexity of managing these AI apps together, I think bring us to a really tipping point in the existing architecture.
There's three key elements when we think about what this new architecture needs to look like. So the first is thinking about, okay, now we have a lot more data spread across a lot more locations. We need new ways to deal with that. So we call that federation, and we'll talk more about that. The second piece is now that I have all that data that's distributed across more places, I need to be able to run analytics on that. So that's the next piece of this new architecture. And then the third piece is being able to do actions based on the things that you're learning from that distributed data and that distributed analytics and being able to do distributed enforcement.
If we think about the security problem just in really simple terms, the principles of zero trust say you have to assume that an attacker has compromised an endpoint, okay? So that's a pretty good assumption these days. So the whole point of security is to identify lateral movement, okay? Lateral movement by definition happens in the network. So we see all of that traffic. The problem is that could be 1,000 times, 3 orders of magnitude more data that's getting ingested into that big giant monolithic data lake today. So it's simply not practical to move all that data in. And what Mike was talking about of this idea of a distributed, federated approach is going to make it work for today's apps as well as for this tidal wave of AI applications that's coming.
And we like to talk about data lakes, data ponds, and data puddles, right? There's going to be data that's distributed across so many different places in your organization and in your cloud service providers, et cetera, that you got to go meet that data where it lives.
But we want to be able to run the analytics close to where that data lives. And the network is going through transformation that's going to allow us to do that. So Cisco recently introduced a category that we call a smart switch. And the idea behind a smart switch is that you can think of it as a single device that has two personalities. One personality is the network processor, and its characteristics are stable, fast as lightning, kind of you don't really touch it and mess with it. You let it do its job, which is moving packets from A to B. Now, right alongside that is another processing element that is a security processing element. And we're utilizing a class of hardware that's made with our partner AMD called a DPU, data processing unit. And you can think of a DPU, it's a little tiny baby firewall on a chip. And we put those two things right together, and so the network processor is moving packets from A to B, and the DPU can be looking at those packets being like, that one's bad. So the intelligence that we're putting into the fabric of the network is really unlike anything that we've had before. And the advantage of this is it creates a very fine-grained set of controls, right? Instead of a firewall living at the edge that's only looking at the stuff coming in and out, we see all the stuff moving around in the innards, which is where that lateral movement takes place. And I think that's one of the key aspects of this architecture, is that with the distributed approach, when Mike was talking about distributed data storage, distributed analytics, the distributed enforcement can live right next to the application and therefore can deliver much more relevant protections for that application.
So it delivers the value of a firewall, but it doesn't increase the barrier that a firewall potentially can produce, because it's picking up that data on the fly in real time and then assimilating it and then coming back and telling you what's going on with those packets.
Yeah, I mean, one of the interesting capabilities that this brings is by being able to put compensating controls right next to a server instance, an individual server instance, is the fact that vulnerabilities are getting exploited even faster and faster, right? And so when you think about a vulnerability that's announced today, there could be an exploit happening in hours, and no security team I know of is ready to patch server infrastructure in a matter of hours after a disclosure. So I think one of the really exciting pieces of this is the ability to apply a virtual patch.
And so this is where AI is so magical. So one of the things we did, which I think is pretty unique, is for every instance of this little baby firewall, we actually have two. So we do what we call a dual data path. So let's think about the software upgrade process. So when we're running version 2.0 of the firewall code, when 2.1 comes out, it sits right next to 2.1, not in a sample of the environment, but everywhere in the environment. And then we run all the packets in parallel, and there's a local AI engine that is comparing the two. So what we've created is a firewall that can upgrade itself. And if you're a firewall administrator, you're like, wait, what?
That's a big deal.
Yeah, it's a big deal.
That's a big deal.
Right?
Yeah.
Right.
So they almost become self-healing, but also self-configuring.
Yes, that's the key word, is self-configuring. We are giving you, the security team, this incredibly granular control, but you can't write rules at that granular level. So the AI is writing those rules. It's self-configuring, self-managing, self-updating, but it's part of this broader architecture that Mike was talking about, where it's a distributed enforcement point that is feeding telemetry intelligently into this hierarchical structure so that the Splunk SOC analyst gets a detailed view without having this untractable amount of ingestion.
This is a major seismic change in terms of what people are going to be able to do.
From an agentic perspective and the massive amount of data that you're generating in Splunk, and then with this infrastructure, what do you say to C-level executives that see this and they want to be able to bring it in for productivity?
And it's a combination of automation plus AI that really unlocks this new wave of innovation. And so being able to take a tier 1 analyst and move them to a tier 3. Now you could potentially say, hey, am I going to replace that tier 1 resource? But I would argue a couple of things. One, there's a shortage of talent. So it's super hard. People don't have enough of these people in the beginning. And two, there's always a long list of things that security teams want to get to that they're not able to because they're so busy with all that triage and manual activity and toil. And so I think what you're going to see is an evolution in terms of the skills and how people grow within a SOC, but I don't think you're going to see a massive change in the number of people that are required. It's just they're going to make better decisions. They're going to do that faster. They're going to be able to shift to being more proactive as opposed to being purely reactive. And I think you're going to see a better security posture because of that.
Dramatically better. Just the talent gap that Mike was talking about is a huge problem. Huge problem. And the AI is going to take a generalist and turn him into someone that can be more effective. And it's useful to just take a moment and recognize the magnitude of the change and the speed of the change, right? If we were talking about a technology that made, like my software development team, 5% more productive, that would be material. And so, at any given year, we deal with budget increments that are like, single digit, either up or down, and we kind of optimize around that.
Sure.
And so, but we're not talking about 5%. We're talking about 50%, 100%, 200%, like these massive, massive leaps in productivity. And so the cynic would say, oh my God, it's to wipe out all of these jobs. I think like human creativity is unbounded. The list of things that I want to go do in product development is so long. I look at that as like, we are entering an age of abundance, right? Our ability to go tackle that list is amazing. Now, I think we'll have to change our methodology, think about how we work differently, but it can't be incremental change.
How do you keep your organizations current on all these technologies? Do you have ongoing learning programs? How do you bring people in to teach them about AI? I mean, your proximity to places like Stanford, Berkeley. I mean, you all can bring in anybody you want from any university in the world.
That's a really important area, and I was actually just talking with the CISO about this today, where they're trying to figure out how do they help their teams embrace these new technologies, these new capabilities. And so what we've done is we have programs where starting with our top layer of engineers, really having them embrace and learn, and then cascade that down and talk about, we have brown bag lunches. Let's talk about a use case and how I was able to use AI to save time or do this, achieve an outcome that I couldn't before. So it's a lot of organic internal activity, along with supplementing that with external. Had some really interesting talks from some AI luminaries recently, and just hearing what they're doing. And there's a lot of collaboration, even though we often compete with each other. There's a lot of collaboration too, on just idea sharing and knowledge. Tom and I will compare notes and, hey, what are you doing on this? What are you seeing over here? And so that's kind of an ongoing, continuous thing that we're doing more and more of.
Another thing that I think has been really productive for us is we have employees that are also faculty members at leading universities and researchers, and we find that the universities are really out in front in some of this thinking because they have the patience and the resources to think 2-3 years ahead, and that continues to bear a lot of fruit, especially in threat research.
It's been a fascinating discussion. I wish you all the best, and look forward to seeing what you all invent. It's just a really fascinating time of the industry.
Yeah,
it is.
It's been
Thank you.
Thank
really
you.
Great. Thanks.
And thank you for watching. For more stories about the tech revolution, subscribe to our newsletters and check out other VB in Conversation videos at VentureBeat.com.